On this video, we like to verify trig identities. So let's take a look at first example. You got secant squared theta cotangent squared theta minus 1 equals cotangent squared theta. You got to prove that left side is equal to the right side. So my recommendation is that you work with whichever side that looks more complicated. So in this example, left side looks more complicated. So I'm going to work with left side and end up verifying that this is equal to cotangent squared theta. Now, when you verify trig identities, it is good to remember that sine squared theta, let's review. Sine squared theta plus cosine squared theta is 1. And from that, we proved that tangent squared theta plus 1 is secant squared theta. And also 1 plus cotangent squared theta is cosecant squared theta. Okay? So let's take a look at this. You know that secant squared theta is 1 over cosine squared theta. And cotangent squared theta is cosine squared theta over sine squared theta. Minus 1 equals. So what happens here? Cosine squared theta cancels out. So you end up getting 1 over sine squared theta minus 1 is equal to cotangent squared theta. Now remember, what is 1 over sine squared theta? That's cosecant squared theta minus 1. Now, how is that equal to cotangent squared theta? We have to go back to the Pythagorean identity. Check this out right here. Cosecant squared theta is indeed 1 plus cotangent squared theta. But look at this. If you move 1 to the other side, you get cotangent squared theta is cosecant squared theta minus 1. So indeed, this is cotangent squared theta. We verified it. Let's take a look at example 1b. So in this example, the right side looks more complicated. So I'm going to work with right side to show that that is equal to tangent squared theta. Well, let's simplify this. Secant theta is 1 over cosine theta. And cosecant theta is 1 over sine theta. What about tangent theta? That's sine theta over cosine theta, and then you get minus 1. So sine theta will cancel out here. You end up getting 1 over cosine squared theta minus 1. And what is 1 over cosine squared theta? That's secant squared theta minus 1. Now, is tangent squared theta equals secant squared theta minus 1? Now, let's go back to one of the Pythagorean identities. Tangent squared theta plus 1 is equal to secant squared theta. So, indeed, tangent squared theta is secant squared theta minus 1. So, therefore, this is the same thing as tangent squared theta, and we verify that these two are equivalent. On this example, the left side looks way more complicated than the right side, so we're going to work with left side here. What's the common denominator? Well, the common denominator is quantity 1 plus sine theta and times quantity 1 minus sine theta. That's the common denominator. And let's see how the numerators changes. So you need 1 minus sine theta. It will be cosine theta times quantity 1 minus sine theta. Over here you need 1 plus sine theta. You need cosine theta times the quantity 1 plus sine theta. Okay, let's distribute the cosine theta. And let's do the same over here. Distribute cosine theta. You get cosine theta plus cosine theta, sine theta, all over quantity. Now let's multiply this right here. What is 1 plus sine theta times 1 minus sine theta? Well, that's going to be 1 minus sine squared theta. Okay, when you multiply this out, you're going to cancel out the middle terms. What happens over here? These two cancel out, they are the opposites. So you end up getting 2 cosine theta over 1 minus sine squared theta. Now what is 1 minus sine squared theta? Well, do you remember sine squared theta plus cosine squared theta equals 1? So 1 minus sine squared theta is cosine squared theta. So what happens over here? Cosine theta cancels out. You get 2 over cosine theta. Now what is 1 over cosine theta? That is secant theta. So you end up getting 2 secant theta. And that's what we had to prove. Now let's take a look at example 3. We got tangent theta over secant x plus 1 equals cosecant x minus cotangent x. I mean, they both look kind of complicated, but it looks like the left side is a little bit more complicated than the right side. So in this case, what I like to do is I like to multiply by the conjugates. So quantity secant x minus 1 all over quantity secant x plus 1, quantity secant x minus 1. Okay, and let's see where it leads to. So when you distribute this, well, let's just leave it alone and see what happens. When you FOIL this out, you're going to get secant square x minus 1. Again, the middle terms will cancel out when you multiply this out. Now, what is secant square x minus 1? Well, that's tangent square x using Pythagorean identity. Okay, so you end up getting, I'm going to go over here, you get tangent x, quantity secant x minus 1 all over tangent square x. So now you could cancel one of the tangent x over here. So you end up getting quantity secant x minus 1 all over tangent x. Okay? Now this does not look like this at all right now. Cosecant x minus cotangent x. But check this out. You could separate this now. So say secant x over tangent x minus 1 over tangent x. Now we're getting somewhere. Notice, you know that tangent x, 1 over tangent x is same thing as cotangent x. Since 1 over tangent x is same thing as cotangent x, I'm going to write as cotangent x times secant x minus cotangent x. Now let's simplify this. What is cotangent x? That's cosine x over sine x times secant x is 1 over cosine x minus cotangent x. That cancels out. Cosine x cancels out. What is 1 over sine x? That's cosecant x. So you end up getting cosecant x minus cotangent x, and that's what we had to prove. All right, let's take a look at example 4. Obviously, the left side looks way more complicated than the right side. So let's try to work with the left side. Let's try to simplify first. Well, you know that sine square x and cosecant square x will cancel out. Why? Because cosecant square x is same thing as one over sine square x. Okay, so these two will cancel out. What about over here? Well, that's cosine square x over 1. What about tangent square x? That's sine square x over cosine square x. Cosecant square x is 1 over sine square x. Okay? So sine square x cancels out, and cosine square x cancels out. So you end up getting 1 over here. So you get tangent square x plus 1. And again, what is tangent square x plus 1? Well, that's secant square x by Pythagorean identities. So it is very important that you know about Pythagorean identities, and we just verified it. All right, let's take a look at last example. We have to prove tangent square x over quantity 1 plus secant x is equal to quantity 1 minus cosine x over cosine x. They both look complicated. So you have to pick and kind of choose which side you want to work with. For me, the left side looks more complicated, so I'm going to try to work with the left side. I'm going to multiply by the conjugate and see what happens. Okay? So quantity 1 plus secant x, quantity 1 minus secant x. I'm multiplying the top and bottom by the conjugate, top and bottom by the conjugate. So you will end up getting, let me just leave the numerator alone and see what happens later. On the bottom, you will get 1 minus secant square x. Now let's take a look at our Pythagorean identity. What is tangent square theta? I'm sorry, I forgot here is x. Tangent square theta plus 1. That's secant square theta. Okay? So what is 1 minus secant square theta? Well, that's going to be negative tangent square theta. So here, 1 minus secant square x is the same thing as negative tangent square x. So what I'm going to do is, I can write it as tangent square x, quantity 1 minus secant x, all over negative tangent square x. And what happens to tangent square x? They cancel out. So you end up getting, well, that's negative 1, right? So you end up getting negative 1 plus secant x, because 1 divided by negative 1 is negative 1. Negative secant x divided by negative is positive secant x. So I'm going to rewrite this as secant x minus 1. Now what is secant x? That's 1 over cosine x minus 1. And what is common denominator? That's cosine x. So 1 over cosine x minus cosine x over cosine x, which is 1 minus cosine x over cosine, and that's what we had to prove. We just verified it.